Hey class, I wanted to go over a couple of the key understandings from 5.1, evidence for evolution. We'll study them more in 5.2 as we dive into natural selection, but you probably read about adaptive radiation, and I'm going to try and just clarify that a little bit more. So two of the understandings are adaptive radiation can explain similar structures with different functions, and isolated populations can produce separate species by divergent evolution. So I'm going to get my pointer here. Adaptive radiation is something you need to know. It says we've got many similar distinct species that evolve quickly or rapidly from a single species or a small number of species. So you start off with one small group and you end up with many different species. And what allows that to occur is the exploitation of slightly different niches. And you got to know what an ecological niche is. It's a position or role within a community of an ecosystem. For example, some birds eat insects that are in bark, and so their niche is to glean the bark from trees to find insects there. So an ecological niche is their role. Okay, the great example that's in your textbook is about lemurs. Lemurs are a great example of adaptive radiation. They only exist in Madagascar. I'll get to that in a second, but let's read what this says here. Species all deriving from a common ancestor have over time successfully adapted to their environment via natural selection. So there's like 100 or 80 to 100 different taxa or species or subspecies of lemurs in Madagascar. And here's the story. So here's Africa, and this little red island here is, well, big red island is Madagascar. About 150 million years ago, it branched off from Africa. There's a geologic extensional zone there, a rift that's splitting. The East African Rift Valley goes through here, the Red Sea, and 150 million years ago, Madagascar separated from the continent. As a result of that, there weren't any apes or monkeys to compete with the lemurs. So the lemurs could proliferate, producing large numbers of offspring, and they could exploit different niches. So because they had such large numbers of offspring, there's bound to be genetic variability in their offspring, and then some of these exploited different niches. For example, I think in the text here it says some are active during the day, some are more active at night, some forage or look for food in trees, and some do better lower down towards the ground. So as a result of that, we have adaptive radiation with many different species and subspecies forming. The other example that I talked a little bit about last class is with the finches. Galapagos Islands. The Galapagos Islands have many different species of finches, and the idea there is that they came from the mainland, as I showed you my drawing last class, and that was a species or a couple of species, and then they evolved to exploit many different niches there. And you can see the difference between them in their beaks. So you've often heard the phrase Darwin's finches, probably. These finches have many different adaptations, but the most obvious is their beaks. So a large ground finch has this big beak, probably better for crushing seeds. It says here crushing bills. And then we have different bills adapted for different food sources like the buds of trees and plants or insects. Okay. And then the last point here is isolated populations can produce separate species by divergent evolution. So divergent evolution is where you have a common ancestor and then separate species are evolving from it. And there's a point where the individuals in a population can't reproduce successfully, and at that point is where they're called a species. Because to be a species, you have to be able to successfully reproduce with individuals of your same population. And in the case of birds, like the finches, they actually might be able to successfully mate, but they don't because they exploit different habitats. And sometimes they're geographically isolated from each other, so they can't successfully get together to mate and reproduce. or they just ignore each other. There's been a lot of research on bird calls and songs, and if the song isn't right, the bird will completely tune out that incoming sound and not be attracted to it as a mate. So in that case, it would be a different species, even though they're in the same place, and they technically might be able to reproduce, but they don't because they don't ever try. So just a few things to clarify on 5.1.